Assalamu alaikum wa rahmatullahi wa barakatuh. Today we have Graham's law for effusion. Now, although this law looks a bit hard, it is rather simple and it requires minimal steps. Right, so for the equation I'm going to pose is argon's effusion is measured at 0.250 moles per second at a certain temperature. Calculate the rate of effusion for helium gas. Now, when I say it's measured at 0.250 moles per second, I mean the rate. So, how can we use simple information to finish the equation off? Now, before you start a test, the teacher will most likely give you a periodic table stating the molar masses for each and every element. For example, here I'll put argon, which is rounded up to 40, and helium, which is about 4. Right, enough talk, let me solve this equation. Now, first of all, I would like helium to go right here, or at rate 2. This is because it's going to be more complex if I put it for R1, because I need to flip the fraction or whatever. So putting it in R2 will be much easier for me and much simpler for you guys. Right, so as we stated, R2 is helium over R1, which is argon, and then equals M1, which is argon, over M2 helium. So what this means is that R2, which we don't know and we're trying to find out, and R1, which is 0.250, as I've stated right here, is equal to the square root, not just a fraction, the square root of M1, which is 40, divided by 4, which is M2, or helium. Now, if you divide both, of course, we're going to get 10, and the square root of 10 is 3.16. That is the square root of 10. So, when we have this and this, we could now cross multiply. R2 over 0.250 equals 3.6 over 1. Right. 3.16 times 0.250 is around, I believe, 0.79. I'll just check just in case. Yep, 0.79. And you divide it by 1, which is still 0.79. And so this is the rate of effusion for helium gas. So I want to move on from this and to what effusion really is. Now, let's say you have a box. I know this is not the best visual, but bear with it. And let's say you have a hole in this box. And in this box, generally, there's multiple gas particles scattered around throughout the box. Now, what effusion really is how long this gas takes to leave the box, I believe, or how long this gas particle leaves the box. It's similar to diffusion, but effusion, what effusion really is when a gas escapes to a smaller space, not just like smaller concentrations as diffusion, because smaller concentrations could vary, could be in very big spaces, such as this. Let's say you have a cologne bottle, and when you open the lid, there's generally going to be an aroma surrounding it, and the aroma is basically gas particles. And when they leave, they go to different places to balance out the concentration or go to lower concentrations. And this is what generally effusion and diffusion is. It's very simple. And this is it for Graham's law and effusion. I hope you've learned, and until the next one.